Hi guys, welcome to the first lecture for early fire detection using image segmentation. So here what we'll do is we will understand that how we can detect a fire, how can we detect a city fire and a forest fire or any kind of fire with Mask RCNN as an object segmentation or an image segmentation architecture. So basically the agenda for this particular lecture is to get you familiarized with what early fire detection is, how is it useful, what benefit can we get from that. The second part will be image localization, is just to get the actual area of the image that where to basically identify where the fire is located. So image localization will give you the exact coordinate of where this particular fire is located. The image segmentation is basically tell you the path of where this particular fire or where the area which has been affected a lot. So basically image segmentation is where we segment these things out. And Mask RCNN is an architecture. So here we will give you a brief introduction about what Mask RCNN is, and eventually over the later modules we will walk you through the architecture of Mask RCNN, how is it used, and how, and eventually we will move to the towards the code that we will be providing. All right. So starting with what early fire detection is. So as you know, fire can destroy multiple building or installations with extremely short time frame. So you might have came across the news that this factory got into fire, that factory got into fire, that particular forest got into fire and burned around thousands of trees, and which is actually the cause of our global warming, which actually adds to this global warming factor. So fire can be extremely dangerous. The value of goods that can be destroyed in a fire is tremendous, and the cost of a life that is lost during a fire is impossible to calculate. The basic idea of the proposed fire detection is to adopt an RGB image. So basically what we're doing is we are providing a colored image which is basically in the form of RGB to a chromatic and disorder management for extracting fire pixel and smoke pixels. So here what we are doing is we are basically extracting the image, we are getting the image out, and then we are basically focusing over the smoke pixels and the fire pixels just to identify where actually the fire is retained. So basically we also aim is to localize the position that where the fire is present so that the authority can take appropriate measures at the right time. So basically if we know where the fire is, if we early detect any kind of fire in any other situation, we will be able to target that and send the and take appropriate measures or send the proper authority at right time, just to avoid the loss, just to avoid the cost of life, and just to avoid any kind of harm to any of the industries or to any kind of forest. So this is what we are targeting. So let's say we have a fire like this, and with the detection of Mask RCNN, we are able to identify that okay, here is where the fire persists, and this is where what the path of fire is. So within the whole image we are just targeting where the fire is actually lies. All right. So moving on, what is image localization? So how do we basically do it? How do we actually identify that where this particular fire is located? So, earlier you might have come across multiple object detection frameworks or detection architectures where you came across that, okay, this classify between a cat and dog. Is there a dog in the image or is there a cat in the image? There's only one object in an image, a dog. You can build a straightforward cat dog classifier model and predict that there's a dog in a given image. But what if we have both cat and dog in a single image? As you can see over your right hand side. So we can train a multi-level classifier in that instance, and now that there's a cat and a dog, we don't know that where in that particular image is that dog exists. So this is where where our target is. This is what we intend to do. that is where the concept of image localization comes into picture. It helps us to identify the location of a single object inside that particular given picture. So if we have identified the location of that particular object, if we have identified that where this particular object lies within this particular image, then we will be easily able to tell that okay, this is where the dog lies, and eventually moving on to our fire use case, we will be able to tell that here is in this particular picture the fire is located. So how does the image segmentation work? So basically image segmentation is a collection of different set of pixels, and we group together that have similar attributes using image segmentation. So basically what we do is in image segmentation, what we do, we basically group a similar set of pixels. So as you can see over the image to your right, the dogs and the pixels related to that particular dog is being segmented as a single image, as well as the second dog is segmented other, and the cat is a third part. We can divide or partition the image into various parts called segments. It is not a great idea to process the entire image at the same time, as there will be regions in the image which do not contain any information. By dividing the image into segments, we can make use of the important parts of the image, important segments of the image, and this is how the image segmentation works. Object detection builds a bounding box corresponding to each class of the image, but it tells nothing about the shape or the of the objects, right? The object detection just tells you that okay, this is where the object lies, but it does not tell you where the what exactly is the shape of that particular object, right? So we not only get the bounding box coordinate, but we want more information out of it. It is too vague for our purpose. So if we are able to detect that okay, this is fire, right, but we are not able to detect that which particular region does the fire lies, this is where the image segmentation creates a pixel-wise mask for each object in the image, and this technique gives us a far more granular results and understanding of the object inside that particular image. So this is basically different types and different applications of image segmentation. So one of the image segmentation use cases traffic control system, wherein you basically segments that okay, which particular area has more traffic and which particular area is densely trafficked right now. Self-driving cars is another use case wherein you identify that where the car exists in that particular image. So basically what you do is you track the road, you track different objects around it, and how you do it with the image segmentation. Why? Because we not only need what is the class of the object, but we also need to know that where the object is located inside our image. Mask RCNN is the architecture that we will use for the purpose of this particular project. Is an extension of a popular faster RCNN object detection architecture. Mm, So what's the difference between faster and mask RCNN is the the faster RCNN generates two things. One is the class of the image, that okay, this particular thing is a cat or a dog, and the bounding box around it. But Mask RCNN add another layer to it and combines the concept of object detection and image segmentation together and gives out an object mask out of it. So Mask RCNN basically takes in the image, do some processing, as you can see the ROI analysis, convolutional class and everything, and different layer basically corresponds to the bounding box as well as the segmentation of that particular image. So this is all for the lecture 1. We will continue for over the lecture 2, where we'll understand the data and we'll understand that how we will go on to the next steps. Thank you and have a good day.